Hi YouTube, welcome back to my channel, Ramsis speaking. What I'd like to show you today is my Amiga 500, which I bought, quite some time ago. It's in great working order. It does have the 1 megabyte RAM expansion with the real-time clock, which is notorious for a very particular failure, and that is the nickel-cadmium battery that is in the metal housing of the expansion, which leaks over time. So I would like to check in this video, or back in May 2020, when I filmed this, I wanted to check whether or not the battery had leaked. And so I opened the expansion up. It's soldered shut from the factory, so it's quite difficult actually to open it, because you have to unsolder it. And yeah, then you have to remove a piece of plastic which is transparent, and you have to remove more solder. And spoiler alert, the battery has indeed leaked, which I'm going to show you in a minute. I do have quite some soldering experience, or soldering, but this project turned out rather difficult, as you'll see later on. So the leakage is right about here, which is, I think it's the negative terminal of the battery. Can't remember. We'll see in a bit. So I'm gonna remove the battery. I start by adding a bit more solder to the terminals, because then it's easier to remove the solder. And then I try to suck away all the solder, the old one and the new one that I just added. And it proved to be a lot more difficult than I thought. So I'm speeding up the process here. But eventually I got the old battery out. Sorry about the noise floor. It's a bit difficult because my laptop is playing back the video as I'm doing the voiceover, and it's struggling with playing back the video and recording audio over it. So it might turn on the fan. So here you can see the leakage. It's the negative terminal on which you see the green stuff, which is actually battery acid that has leaked onto the board, and it can cause destruction, unfortunately. So it has to be removed and neutralized, so to speak. I'm using white vinegar to do this, and let me tell you at this point that I got the inspiration to do this video from someone called Jan Bieter. He's a fellow German YouTuber. He's quite popular and well known in the modding community, I believe, unlike me, but well. So I'm basically replicating his efforts on my own Amiga RAM expansion. It's a A501, as you can see in the it's printed on the PCB. At this point I'm trying to get the vinegar on in order to neutralize the battery acid that's on the board, and it's working. You can see I'm just removing the acid, and it's going away. This process actually took quite some time. I'm not showing every iteration, but I did this, I think, 3 or 4 times at least, because it's more than it looks, and it leaks into the I think it's some sort of fiberglass, PCB like this, so it leaks into the fibers, and it's quite difficult to remove it. So I'm scratching a bit and looking to get it off as good as I can, which is not easy. So after some time, you can see the acid is basically gone. So now we have to clean it up with some isopropyl alcohol or isopropanol to get rid of the of the vinegar, basically, and yeah, the dirt. I'm lucky. In my case, I'm lucky. If you've seen the video on Jan Bieter's channel where he does the same project, basically, his A501 unit is quite kaput. So he's doing a good job at repairing it. But in my case, I got lucky. Basically, it's not that bad. What I did want to do is replace the NICD battery with a button cell, with a CR2032. And to do that, you have to remove a few components and replace them. This was a still from Jan Bieter's video where he shows the instructions, what you have to do. We have to remove 2 resistors, which are R913 and R911, and a diode, I think. Yeah. So what I did here is I think I cut one leg of the diode to minimize its exposure to heat, and then I desoldered the other one. And then I removed the other leg. We have to reuse the diode in another spot, so we can't risk it getting damaged. So yeah, the spot where the diode sits, it's replaced with a bridge, a wire bridge. So that's all components removed. Now I'm removing excess solder. To free the holes, the vias in the PCB, where we have to resolder other components. Then I cut a little bridge of wire. It's from an old, or from another resistor, I think. I always keep those. I have quite a box of resistor legs used for repair work. Can't remember why I soldered it from the top first, but I'm sure there was a reason. And then soldering the bottom. Not sure if you can see it, but the bridge is in. So now I tested the diode to make sure it hasn't died from the heat. and it's still fine. So now I'm soldering it in. Again from the top first. Can't remember why. Maybe the wires were a bit, yeah, still filled with solder. As I said, it's quite difficult to work with these older PCBs. They tend to have rather large ground planes, and those suck away the heat, and it's quite difficult to even melt the solder sometimes. So the diode is in. Sorry for blocking blocking the view with my head. I had a DSLR mounted on a tripod, and the lighting wasn't quite good. I had a 300 watt halogen bulb, which was hot. It was so hot under this light, and it stank because it was an older one. I don't even have it anymore. It was quite the task to do this. So you see me speeding through the process again, because yeah, it took some time. I'm basically now I'm replacing the caps, the electrolytic capacitors, which tend to leak too, and before I'm closing it up again, I would like to replace those just for good measure. And I'm putting in brand new ones, making sure I get the polarity correct. The capacitor legs, which I just trimmed off, are kept, of course. I always keep them for repair work, as I mentioned, and it's quite handy to have those bridge wires around. Even if you just repair a board with broken traces or something like that, it's so useful to have those. But yeah, those older boards, man, can be a pain in the neck. So heating it up, putting the capacitor in, heating it up again, and then finally reflowing it, because it just won't work otherwise. Unfortunately I didn't have a desoldering gun at the time. So looks good. Next, for the battery holder. I plan to mount this on the outside of the aluminum or aluminium housing for easy replacement, because the cell, yeah, could die. I don't know. I think it's still holding up today, over 3 years later, but if I want to replace it, I don't want to open the whole aluminum cage again. So I'm gonna mount this on the outside. Now, concerning wire routing or routing, I did mess up here quite significantly. I had to redo things twice because, yeah, the expansion housing wouldn't close up anymore, but yeah, sometimes if you don't plan ahead too well, things can go wrong and you have to take a step back and redo things. That's normal. It's part of a project like this if you don't plan ahead. Like I didn't. So the wires are installed and they are attached to the battery holder. In goes the battery. And for good measure, no pun intended, I measured the voltage that we get. The battery is of course there to keep the time, the real-time clock of the A501. I think that's the only purpose of the battery. Otherwise you wouldn't even need it. Okay, so we are getting 3 volts. And then I proceeded to clean up the mess that I made. Yeah, no, didn't really make a mess, but there's always flux residue and dust and stuff like that. And isopropanol makes it easy to clean it up. So that's what I'm doing here. Okay, so that's done. Next, we clean up any dust that still remains on the board. There's not a lot. I mean, it's in its housing. Not much gunk and stuff gets in there, but reassembling the expansion took longer than expected due to poor planning, as I've hinted at before. I thought I'd leave this in anyway because yeah, so you can see how easily things can go wrong if you don't plan ahead. And yeah, lesson learned, I guess. Yeah, so I had to remove the battery and redo the cables, or wires, I should say. So now I'm sticking them through a hole in the PCB, which ended up being a good idea, but I still had to compensate. Well, you'll see. So reattaching the wires. and it fits in the housing. And now I'm trying to close it again. I had to trim off a bit of the transparent plastic to make it fit, but that was no big deal. So yeah, you can see me trimming a bit of the edge off, so I wouldn't have to do it all over again and find a place for the wires to go. So yeah, that's that. Now I did put some electrical tape around the wires just to protect them from the sharp edges of the aluminum or aluminium or whatever you want to call it. I'm not a big fan of electrical tape. It tends to come loose, and yeah, not a big fan of it. It leaves sticky residue over time, but in this case I thought, well, okay, let's use a bit of it. Can't hurt. So now yay, it fits back together. But I'm still struggling putting it all back together. Yeah. There we go. And soldering it back together was smooth sailing. No problems there whatsoever. I was afraid of melting the wire insulation when heating up the one spot, but didn't happen. It was just fine. And the third spot is soldered shut. I didn't use an excessive amount of solder because if I have to open it up again at some point, I don't want to be struggling as much as I did on this occasion. So we are getting close to a first test. I used something called TISA power strips. It's some sort of very strong, thick, double-sided tape meant for like towel holders and such, to be stuck to the wall. And I thought it was a good idea to use that for the battery holder, to sort of attach it to the outside of the aluminium case. It proved not as strong as a bond as I'd hoped, but well, it worked out fine in the end for the purpose. This Amiga is my own computer. I'm not planning on selling it or something like that. I'm not offering modding or repair services. So this is just for myself, and yeah, it's fine. So the RAM expansion is back in. The battery holder fits in there quite well. No problems. I put the cover back on. And there we go. closed. Now, to test it, I must admit that I had to research on how to set the clock on the Amiga 500 and save it, and save the time setting. I'm still not sure if I did it correctly though. So yeah, sorry if you'll be screaming at the screen in a second and think, you idiot, doing it wrong. Sorry for that. There we go. The little Sony TV you see there used to belong to my sister. I like it very much. It's got a small Trinitron tube. I think it's a 13 or 14 inch one. So setting the time, yes, it's almost 3.5 years ago now that I did this. I'm not sure what I'm trying. I'm opening a terminal. I'm typing in something to save the time. Not sure if this is needed. I'm not very familiar with the Amiga. Never had one as a child or as an adolescent. Back a few years ago, I thought, why not buy an Amiga? So I'm removing the power, and or I'm actually disconnecting the power supply for half a minute to make sure the coin cell provides the necessary power to the real-time clock. And now I'm reattaching the power and rebooting the machine. It takes some time because it boots from a floppy disk. It's not very reliable. I got it to get stuck on the boot screen twice or so. Might have to clean the drive at some point. A success. And yes, this footage is old, very old.
Yep. Cool.
There you have it. The time was retained. And it matches the actual time. Very cool. So, thank you very much for hanging around and watching my video. This one was tough to make. As I said, the lighting was problematic, to say the least, and yeah, I hope you enjoyed watching it anyway, and enjoyed watching me messing around with electronics, which I love doing. So yeah, stay tuned for the next one. Bye.